Clemson University is in the midst of its sustainable construction campaign. By 2020, the university has set a goal to use 20% less energy and be 10% more renewable by 2025. Also, new buildings must be LEED certified. Perhaps one of Clemson's largest steps towards achieving the aforementioned goals is the Lee 3 extension. Lee 3 is a LEED Gold certified building with many sustainable features.
One of the main sustainable features of Lee 3 is the 8-zone radiant heating and cooling system, and is one of the first projects worldwide to use this kind of system in a mixed humid climate. Another sustainable feature of Lee 3 is the geothermal water-to-water heat pump system, which consists of 46 400-foot deep wells that are located under the courtyard in front of Lee 3.
One of Lee 3's design features that noticeably impacts all of its occupants is its incredible use of daylighting. 24 skylights equipped with daylight sensors make it possible for work to be completed inside without additional lighting on a cloudy day. Arguably the trademark feature of the building, Lee 3's green roof is the largest on a public university campus in the southeastern United States. The roof acts as a method of building insulation without absorbing excess heat.
The green roof also helps with stormwater management, retaining 48% of annual precipitation. A nearby reservoir collects site runoff, treats it, and redistributes the water to campus. Also, the building was built on a disturbed site and replaced 128 parking spaces, decreasing the amount of stormwater runoff. In addition to stormwater management, Lee 3 conserves water by using high-efficiency dual flush valves and sensored faucets. These systems reduce the building's potable water use by 35%.
Two of Lee 3's 4 facades are comprised of highly efficient window walls. These window walls contain a transom window and operable window system that aids in the ventilation of the building. The building uses sensors and internet data on a daily basis to determine the temperature, humidity, and pollen count. If the conditions are right, the transom windows will open automatically, and a light on the wall will turn from red to green, signaling the occupants to open the lower operable windows. This system makes the interior of Lee 3 comfortable on even the hottest days. Drawing from its sustainable roots in Lee 1, Lee 3 was constructed to emphasize structural integrity and design. The use of tree columns to support the building instead of large, fat columns is an example of how building materials were conserved without sacrificing the quality of construction.
In addition to material conservation, Lee 3 was built using materials that exceeded the LEED requirements for indoor environmental quality, and 95% of construction waste was diverted from landfills. In order to keep the building low on landfill waste, recyclable material collection containers are placed conveniently throughout Lee 3. In the future, Lee 3 plans to add a solar panel array that will make the building net zero energy. The building is already ready for this addition because it was in the original plans, but limited funds didn't allow for it at the time. Also, Lee 3 has a conduit for future electric car power stations that will be connected to the university public transit system.
Plans are in place to construct multiple engineering buildings in the future, with Lee 3 Courtyard being the centerpiece of the complex. The building serves as a model for the future and will always be one we can learn from.